Key Stage 3, Level 6, work based on the National Curriculum level descriptors. Starting off with a section on number. Approximations. When we get an answer on a calculator, we sometimes have to approximate the answer to make it look more sensible. And one way is to do decimal places, or DP for short. So if we're going to round these numbers to one decimal place, we write down anything that's in front of the dot, anything in front of the decimal place, and then count the one decimal place. Looking at the next figure just to see if it's 5 or more. So anything in front of the dot, count one figure, look at the next figure to see if you need to round it up. Anything in front of the dot, count one figure, look at the next figure. If it's 5 or more, then you round it up. Anything in front of the dot, count one figure, then look at the next figure. So I need to round that up to 10, which will actually turn that into an 8. But we must put the naught afterwards to show we've done one decimal place. Now let's round these to two decimal places. So we write down anything in front of the decimal point, count our two places, look at the next number to see if to round it up or not. Write down anything in front of the decimal place, count our two places, look to see if we need to round up. Anything in front of the dot, count our two places, look to see if we need to round up. So that's actually going to turn that into a 10, which will mean I'll have to do that. And we must put the naught in there to show we've done two decimal places. Anything in front of the dot, count our two places, look at the next figure, that will round that up to 10, that will round that up to 10, which will actually mean I'll have to put 817. And again, we do need those noughts to show we've done the two decimal places. Rounding to a specified number of places is a way of approximating an answer. We can also approximate answers by using significant figures. Sometimes SF for short, sometimes SIG FIG for short. So let's correct these to one significant figure. Now when we do significant figures, we look at the first figure that we come to. So there's our one significant figure. There's our one significant figure. There's our one significant figure. So for significant figures, we count from the first figure that we see. So this is 4. The next number is not 5 or more. That's the answer. This is 6. The next number is not 5 or more, so that's it. Or is it? Remember, we're approximating here. So this is actually 6,473.985. So how can 6,000 round to 6? We've actually got to make sure the place value is correct as well. So this says 6,000 and, this would have to say 6,000 and. One significant figure here is the 6. No rounding up to be done. Now let's correct to two significant figures. In other words, the first two figures that we see. No matter where the two figures are, it's the first two figures that we see. And in this case, we don't count those noughts, but we take the 8 as our first significant figure, and then we must take the naught as our next significant figure. So significant figures means the first two figures that we see, or in this case, the first figure followed by the naught. Okay, so this is 56. That 7 will round it up to 57. This is 4,400 and that 6 will round it up to 4,500. That 6 will round up to 0.0055. That 2, no rounding up to be done there. And that 6 will round that up. That is significant figures. So significant figures count from the first figure you come across the number of figures you're asked to count. Sometimes we're asked to estimate an answer. So to check using estimation. So we have a calculation to do and we want to see if our answer is correct just by estimating. So what we do is we round each part to one significant figure. So 56.23 to one significant figure is 60. 32.8 to one significant figure is 30. And the whole point is I can work this out in my head. An estimation is something you can work out in your head based on the actual information. So this is going to be one significant figure is 90 divided by one significant figure which is 30. So my answer to this calculation should be around about 3. That's an approximation. So if I round each of these to one significant figure, 638, that's almost 20 to one significant figure. To one significant figure this is 10. 6 2s are 12, and we need 1, 2, 3 noughts on there. And divide by the 10 at the bottom. The whole point about an estimation is we round the figures to one significant figure and we can then do it in our heads. Now on some occasions we might be able to use two significant figures. Let's look at this one again. We'll leave the top just the way it is, but the bottom, if I rounded that to two significant figures, it so happens I can still virtually do this in my head. I can cancel the 15 with the 600 and get 40 there, and 40 times 80 is 800. This is a better approximation to that. However, that is good enough for most purposes. So estimation, we round things to one significant figure and do the calculation, but on the odd occasion we might spot something like that. To recognise prime factors and common factors. First off, let's look at prime factors. What are the prime factors of these numbers? Well, first off, let's see what the factors are. The factors of 12 are all the numbers that divide exactly into 12 with no remainder. The prime factors are any numbers within that list which are prime numbers. So 2 and 3 are the prime factors of 12. Let's look at 20. These are the factors of 20 because all of these numbers divide exactly into 20 with no remainder. So they are the factors of 20. Of those, these two are prime numbers. Therefore 2 and 5 are the prime factors of 20. Let's look at 45. They are the factors of 45 because all of those numbers divide exactly into 45. These are the prime factors of 45. We don't have to list the factors, but if you do, it's easier because you can actually see what you're doing. It's like showing you working out. Prime factors are factors which are prime numbers. Now common factors. We need two numbers, or possibly three we could have. And we need the factors of 12. We need the factors of 20, we've got them up here, and we look for any number which appears in both lists. Well, 1 does, 2 does, 4 does. Therefore they are the common factors of 12 and 20. 20 and 45, they are the common factors because they appear in both lists. 24 and 30, well, it was up to you whether you list all of those and list all of those and pick out the common ones, or whether you do it in your head and be able to spot which numbers would appear in both lists. Now when we get larger numbers, then we need to think about something called a factor tree. This is not the only way of doing this question, by the way, but this is the way I tend to do them. If we're asked to find prime factors of a large number, we do what is called a factor tree. We need a prime number that goes into 140. 2 does, because it's 2 70s.